Good evening, everybody. Today is my fifth presentation. The topic is temperature gradient tunnel. It is temperature gradient tunnel or CO2 temperature gradient tunnel. When you are incorporating both temperature and CO2, it becomes CO2 temperature gradient tunnel. This is very important simulation model. This technology is developed by us. So I will come back to the fundamentals of simulation chamber, which is temperature gradient tunnel. In my previous presentations, I have talked about open top chamber, CO2 elevated open top chamber, both temperature CO2 and ozone. I have also talked about free air CO2 enrichment technologies, where in open atmosphere you enrich CO2 temperature and ozone for climate change crop simulation model. Here this technology is a temperature gradient tunnel. It's a tunnel. It can be from 20 meter, 30 meter or 40 meter in length. The height it can be 4 meter or 5 meters, and width it can be 4 or 5 meters. Based on your crops height, you need to develop and design first the temperature gradient tunnel. The tunnel part you need to develop. First I will explain to you the construction of the gradient tunnel. You can have a tunnel which is having 30 meter or 40 meter in length, is made of iron structure, and it is fully covered with polycarbonate sheet, 6 mm one side UV polycarbonate sheet, so that it has got 85% light transmission capabilities. Now the question is, there should be some entrance, the front door, and at the back side you can have also one more door, that is for exit. Now the question is, how do you create gradient atmosphere inside the tunnel, the gradient temperature profile? Fundamentally, when I talk about the gradient atmosphere, it is obviously comparing to the ambient temperature. Imagine if your ambient temperature is 30 degree temperature, 30 degree centigrade, you want to have ambient that is the gradient atmosphere inside that tunnel 30 plus 5 degree or 10 degree. That every 2 meters there will be a temperature variation, and you can have 32, 34, 36, 38 and 40 degree centigrade profile that will be created inside the tunnel. Now imagine a situation, if you have a 40 meter or 30 meter tunnel, every 2.5 meters or 3 meters or 4 meters there will be a gradient atmosphere created such a way that will be first gradient will be 30 plus 2 degree, the first one, and gradually 2 degree increment will be there at the end. Now question is, how do you do it? How do you create gradient atmosphere inside the tunnel to be created? There are few ways to do that. First of all, there must be a hot air blowing system, and that blowing hot air, once you are taking this hot air from one direction to another direction, and you are also controlling the airflow, and in front of air blowing system you have the heating system arrangement, so that when you blow the air, when the heater is on, gradually the hot air is flowing through the across the tunnel and you are taking air out from another direction. So initial level the temperature will be more, so gradually from high temperature to low temperature zone it will be created, and airflow rate shall be controlled such a way so that there is a gradient profile created inside the tunnel. This is one way of doing it. The other way one can do it, there are set of heaters can be mounted at the top of the tunnel based on the whatever temperature you are trying to achieve in this particular atmosphere, and gradually the number of heaters, if you want to have the more temperature to be created, accordingly number of heaters can be created more across the tunnel. Now there are 4 or 5 zones can be created, that is the imaginary zone. Now every 2.5 or 3 meters there will be mounting facilities for temperature, humidity and CO2. As I have told you, it can also you can have CO2 gradient tunnel. So when you mount both temperature and CO2 and humidity, and with a data logging and controlling action, accordingly your CO2 discharge line can be also put across the tunnel, and there will be a CO2 cylinder gang from there itself with a solenoid control. You will be purging the CO2. Again, this system can be made completely automatic system. Now imagine a situation when you have a tunnel of 30 meters. Every 4 or 5 meters you have the mounting facilities of CO2, temperature and humidity, and you can monitor online that what is the existing level of CO2 as well as the temperature. Now based on the set point of the temperature you can on and off the heater and also CO2 regulation. Let's say if you are deciding that first tunnel compartment up 3 meter or 4 meters you want to have ambient plus 2 degree with 400 or 450 ppm CO2. After that you want to increase another 2 degree, your CO2 level can be 500 to 550 ppm. Based on the set point you can develop the controlling action. So basically this is for the temperature and CO2. The entire system can be designed, and whatever signal output, whatever CO2 sensors output can be taken into PLC, that is the control system, either through wired or wireless communication system you can do it. And beyond that, when you covered the tunnel, so there is excessive heat also is generated. In order to reduce that, you can have also cellulosic pad that is mounted at the back or front or side, so that during summertime excessive heat can be reduced. So those temperature gradient tunnel can be helpful for screening of different varieties. When you are growing plants, if you want to study the impact of temperature or CO2 in one go, like as I have told you, you are going to grow similar kind of crops across the tunnel, and if you have the temperature and CO2 variation every 4 meter or 4.5 meters, based on the length, if you have 30 meters you can divide 5 segments together, imaginary segment, or if you have 20 meter you can decrease or reduce the temperature zone so that crops can be grown, and you can see the variation how different temperature and CO2 level is impacting the plant growth and responses. So it is essentially going to help us or researcher to develop the which temperature and which CO2 level is ideal for the growth. It's a basically screening job what you are doing. Now I'm just correlating temperature gradient tunnel with open top chamber. In open top chamber, CO2 elevated open top chamber, what I have told, in open top chamber you can have single point CO2 and single point temperature monitoring and control option. One OTC to be designed throughout the crop season for a single CO2 level and temperature level. Now, if you want to have 5 different temperature zone, you need to have 5 OTC altogether. If you want to have 5 CO2 level, you should have again 5 OTC, that is designed or defined or with temperature and OTC, both CO2 and temperature monitoring facilities to be developed. Now, instead of 5 OTC in one tunnel, one can carry out the whole experiment for screening purpose. So it is a very cost-effective solution while we are working on simulation model, and also since it is a closed chamber, your CO2 loss can be restricted. That is what, because in open atmosphere, in OTC or phase ring, what is happening, you are discharging CO2 because of top portion is open, so CO2 loss will be more. Even for the phase, CO2 loss is also more because it is totally in open condition. So CO2 is not very cheap in India. In order to save CO2 cost, the consumption cost, temperature gradient tunnel is one of the most affordable simulation model that we have developed for the customer, for the scientific community. Now coming back, the instrumentation part, as I have told you, the structure, apart from the structural part, instrumentation part is very, very important. So selection of sensor based on the working range, selection of temperature sensor, selection of humidity sensor, selection of CO2 monitoring system, everything for controlling action, data logging. It should be very, very precise so that on real-time basis, whatever temperature, whatever CO2 level we want to achieve, and we have to have a feedback and controlling action mechanism in place so that that particular environment is created inside the tunnel. This is all about temperature gradient tunnel. We have developed many temperature gradient tunnel for various research institute. The first temperature gradient tunnel we have developed for IRI, that is for Agricultural Physics Department. Even we have developed for Environmental Science Department for IRI. There are 2 chambers for Environmental Science Department and 2 chambers for Agricultural Physics Department. Mostly they work on rice, wheat and various other crops, and this is not a very big chamber. It is, I think it is 25 feet, close to 8 meter into 2.5 meter into 2.5 meter. This is not a very, very big tunnel, so that if your tunnel size is not big, you cannot have the very long gradient atmosphere created inside the tunnel. So that is one limitation, so that your tunnel size should be much bigger, and if you have more number of seedlings to be grown, so that accordingly your tunnel size has to be decided. There are 4 tunnels that we have developed for IRI, Indian Agriculture Research Institute. Is a ICI Research Institute. Apart from IRI, we have developed 4 temperature gradient tunnels for CRRI, Central Rice Research Institute, Co2. That is around 10 years back we have developed it. they mostly work on rice. This tunnel is also close to 8 or 9 meters in length, 2.5 meter height and 2.5 meter width. There are 4 tunnels we have developed. So having 4 tunnels, you can have variation of temperature for each tunnel that can be created. One can be kept for control, one for 1 ambient plus 3 or 4 degree, another it can be 4 to 8 degree, so that those kind of temperature zone can be created for studies purpose, or different varieties or different crops can be grown if you have more number of tunnels. Apart from CRRI or NRRI, the current name is National Rice Research Institute, we have also developed for IIVR, that is Indian Institute of Vegetable Research. That is also more than 10 years back we have developed 4 tunnels for them, and those tunnels are little bigger. They are working on various vegetables and we have been supporting their system for almost 10 years, so it is working. We have also worked with Assam Agriculture University, their plant physiology department. We have developed I think 3 or 4 numbers of temperature gradient tunnel, and it is also again close to 10 years we are supporting them, and they are carrying out various research activities. These are all pure temperature gradient tunnel. This is CO2 is not included. CO2 is not the concern for them, so that it is only temperature gradient tunnel. The 4 systems, 4 institute, what I have told, they are all purely temperature gradient tunnel. Recently we have done a project for Equisat Hyderabad. This is the International Research Institute. They mostly work on legumes, and this is a very renowned research institute. We have developed the first CO2 temperature gradient tunnel. We have developed 20 meters tunnel with 2.5 meter height and 2.5 meter width. There are 2 tunnels that is developed for them, and it has got both controlling action for CO2, temperature and also cooling system. The entire system is fully automatic. We have provided the wireless communication system, complete structure made of polycarbonate and iron, and it has got infrared heating system, and we are creating various temperature zone inside the tunnel along with the CO2, that is from 380 ppm to 800 ppm CO2 level, the gradient profile we are creating inside the tunnel. So there are 2 tunnels we have developed for them around 2 years back we have completed. So this is a big project that we did for Equisat. So those are the functional projects working all over India. So if you compare the advantage and disadvantage of all the technologies, all the simulation model I have told, either it is open top chamber, or phase system, free air CO2 enrichment system, or FET system, free air temperature enrichment system, or temperature gradient tunnel, both are having its own merits and demerits, but all the systems are functional and it gives very good result. And when you expose those plants into such an environment, you are definitely going to get positive results. So based on the scientist's choice that which model they want to pick up, But ideally speaking, you can start it from plant growth chamber, then probably OTC, then phase technology, then temperature gradient tunnel or CO2 gradient tunnel. One can do it. It is a choice of the customer which model they will be selecting for their research purpose. So I have nothing much to talk about the temperature gradient tunnel. Again, those technologies are very, very complicated technology. I am not getting into the sensor selection, what kind of sensors you are using. I only told those are the monitoring facilities, CO2 monitor, what should be the working range. That is part of the system we developed. Again, it is not the concern of the scientific community how you are developing the system, but it is very important to know the kind of system we are providing and the application part. Our focus should be mostly based on whoever is working on those models based on the working. So one cannot develop simply just like that the system. It has to go through various discussion, the kind of crops you want to grow, what is the gradient that you want to develop, and what is the CO2 gradient profile that you want to create inside the tunnel. If one require temperature controlling action or cooling system, those things can be decided based on that. First system has to be on that basis, system has to be developed for that specific application. There is no straight cut solution that this is temperature gradient tunnel we are establishing. It's a purely application, and if application varies from customer to customer, so system designing, system integration, data logging, control, everything will be based on the application. So if anybody is having any kind of doubts or requirement, please do contact us, and you can also log on to our website www.genesisindia.net.in, or you can mail us on ngt.india@gmail.com. And our company name is Genesis Technologies, and we thank you very much for hearing this small presentation or small talk. Hope this helps you in understanding the concept of temperature gradient tunnel or CO2 temperature gradient tunnel. Once again, thank you very much for hearing me out. Bye bye.